Hi everyone, welcome back to video number 3, and where we were on number 16, and I was going to show you a faster way to do this problem if you're interested. So if we start with the $32 shirt, what we can think about is instead of figuring out what amount of money is 15% of 32 and then adding it, we could say to ourselves, if 15% is discounted, that actually means I'm paying 85% of the bill. So if I took $32 and multiplied that by 0.85, which is 85% as a decimal, that could take care of the amount that I'm actually paying. Now, the sales tax, what this means is that you're paying 100% of the t-shirt sale. So you're paying the full $32, the full 100%, but then you're adding on an extra 7% for tax, which means you're paying a total of 107% beyond. And 107% as a decimal, if you move it over twice, is 1.07. And so if you don't trust me, please check me now. You have $32 times 0.85 times 1.07, excuse me, you would get the exact same answer of $29.10. So whichever way you prefer. I started with this one because this is how we started back in the first unit. But this way, for those that are ready for it, I think this is a faster way if you're interested. Moving on, we're just solving some equations here. Back again to the first unit. For number 17, if I distribute, multiplying by 1/3 is the same as dividing by 3. So 9 divided by 3x is 9x divided by 3 is 3x. Negative 18 divided by 3 is minus 6. Equals 4x. Here we are distributing a negative 1, so this becomes negative 3x plus 6. Combine like terms on this side, always combine before you move things. So we'd have 3x minus 6 equals 4x minus 3x, same sign, or same side of the equation. Combine it to be 1x plus 6. Now that the variables are on different sides, now we can subtract it to the other side. So we have 2x minus 6 equals another 6. Add the 6 to both sides. 2x equals positive 12. So that means that my x value is 6. The next equation, my goal is to get x alone. And the 4/5 is being added to x, not multiplied. So we cannot use the reciprocal here, because if we subtract 4/5 from both sides, if I wrote it more nicely, we would have x equals negative 7/8 minus 4/5. And if I'm adding or subtracting a fraction together, or fractions, I need a common denominator. So my first number that 8 and 5 go into is 40. So this fraction has the denominator of 5, and it needs the 8. So we multiply by 8 over 8. This fraction has the 8, so we need the 5. So we'd have x equals negative 35/40 minus 32/40, which would get you a negative, let's see, negative 35 minus 32 is negative 67/40. And remember, you always want to check to see if you can reduce this if possible. But I don't think anything goes into 67 and 40. So we can leave it as negative 67/40. The next pieces are either equations or inequalities based on the problem. So let's start with number 19, which is absolute value. And remember, your goal is to always get the bars alone. And to do that, we would move this unattached 4 first. So we'd have 3 times the absolute value of 2x plus 4 equals 9. Remember, we cannot distribute the 3 in. Instead, we want to get the 3 away. So we would divide both sides by 3 because it's multiplying the bars. So we'd have the absolute value of 2x plus 4 equals positive 3. Now that the bars are alone, remember that this says distance is positive. So because distance is positive, this is allowed. So we were allowed to make 2 equations based on the meaning of absolute value, that this number inside could originally start as a positive 3. So we had 2x plus 4 could have equaled 3, or the number inside the bars to get a 3 out could have been negative 3 originally. So 2x plus 4 equals negative 3. So I'm going to come up here to solve both of them. 2x plus 4 equals 3. If I solved this, I would get 3x equals negative 1, or excuse me, 2x equals negative 1. If I divided both sides by 2, I would get that one answer is negative 1/2, which on a number line would be between negative 1 and 0. So there's my first answer. My second possibility, 2x plus 4 equals negative 3. If I subtract the 4, I would get 2x equals negative 7. And if I divide it by 2, I would get negative 3.5 or negative 7/2 is my second answer, which if I kept going on my graph, negative 4, my second dot would be between negative 4 and negative 3. Because this is not an inequality, my answer or my graph just has 2 dots, and that's it. Remember, absolute value generally always has 2 solutions if distance is positive. Number 20. This looks like an inequality this time with the word or in the middle, so as many answers as possible. So we want to solve these separately. So for this first inequality, we'd have negative 4u is greater than or equal to 8. When we divide by a negative 4, remember we have to flip the inequality sign to keep truthfulness. And so my first part is u is less than or equal to negative 2, or if I solve the second part, we'd have 2u minus 6 plus 8 is greater than or equal to negative 10. If I combine like terms, negative 6 plus 8 is 2. So we have 2u plus 2 is greater than or equal to negative 10. Subtract my 2 away. 2u is greater than or equal to negative 12. Divide by 2. The inequality does not flip this time. The number is not negative. So this is u is greater than or equal to negative 6. So we have u is less than or equal to negative 2, or u is greater than or equal to 6. So let's see what that looks like. If I start 0, negative 2, negative 4, negative 6, 2, 4, 6, we would have, okay, u is less than or equal to negative 2. So that would be closed dot downwards. And in this part, u is greater than or equal to negative 6. That would be a closed dot upwards. So if this was an and problem, my answer would only be between. But it's an or problem. So or means I want as many answers as possible. So this top part starts at negative 2 and goes all the way down to negative infinity. And this part starts at negative 6 and goes all the way up to positive infinity. So it looks like to me that the entire number line is covered. So my answer here, because it's an or, is all real answers or all real solutions. So not only should you color in the number line completely, I would also mark for yourself the symbol for all real or write all real solutions. Next example. Looks like we have absolute value bars again. This time it's an inequality, but we still need to get the bars alone. So if I divide both sides by negative 2, I would get the absolute value of x minus 1 is divided by a negative. This must flip, so it's less than or equal to negative 6. Now, the bars are alone, just like number 19. But we need to think about what this says. This says distance is less than or equal to a negative number. This negative gives me pause. Distance is always a positive number. So I have the sentence, positive number is less than or equal to a negative number. A positive number can never ever be less than a negative, so this answer is no solution because this statement is false, which means that your answer, your number line, would be left blank. Last one with the review of inequalities and equations is one of these and sandwiches, or and-wiches, as a lot of you like to say. And your goal is to get the x alone. So again, pretend this isn't here for a second. If that's not here, the first thing you would do is subtract 6 from both sides. But this piece is here. So because it's a double inequality, you would subtract 6 from this piece also. And so if you do that, you'd have 3x in the middle is less than or equal to 12 over here, which is greater than negative 30. If my goal is still to get x alone, the only thing in the way is that multiplied 3. So I would divide every single number I see by 3. If I do that, I'd get x is less than or equal to 4, and at the same time greater than negative 10. So because this is an AND problem, I need to look for overlap. So if I cheated a little bit on the graph and had negative 10 here and 4 here, 0 somewhere in the middle, I'm going to have an open dot on negative 10. I'm going to have a closed dot on 4. And the long way, what this means is x is less than or equal to 4. So here and down. And this piece means x is greater than negative 10. So unlike the previous problem number 20, this is an AND problem, so we're only graphing where these two things overlap. So these two blue lines only cross in between these two dots. So your answer will be open dot, shading, closed dot. Last but not least, this is what we've been working on the most recently. What is the equation of the line graph below? Use y equals mx plus b form. And so what we want to look for on every problem is what the slope is and what the y-intercept is. So if I looked at this first example, my y-intercept where it crosses the x-axis is here at 0, 1. So I know that my equation so far would be y equals something plus 1. My slope is determined by the point I just found and another nice point that crosses. As I scan my line, this looks like a nice second point. There at 1, 2, 3, 1, 2, 3. If I draw a little triangle, I'm going to see that the slope is up 2 over 3, which means that my equation would be y equals positive 2/3 x plus 1. The 2/3 slope always goes next to the x, and the y-intercept is afterwards. It makes sense that my slope is positive because my line is increasing from left to right. The second example, again, if we're trying to find the equation y equals mx plus b form, my y-intercept this time looks like it's up at 0, 4, which means, again, my equation is going to start as y equals something plus 4. My slope this time, if I scan to find another nice point, this looks like a nice point and so does this. So I can draw a little triangle from here to here. And if I do that, it looks like I'm going down 2 over 1. If I did it again, I'm still going down 2 over 1. So because slope is rise over run, I'm rising or really falling 2 units and then running to the right 1. So my answer would be y equals negative 2x plus 4. I would also accept negative 2 over 1x plus 4. Last two problems, the two kind of exceptions to the rule. We want to find the equations of these. And so if we look at part C, notice that this graph is perfectly vertical and it hits the x-axis at x equals 4. So the reason that my equation is just x equals 4 is because all the way up and down this line, the value of x never changes. X every time is always 4, and y is the one that changes. So if you ever have a perfectly vertical line, this would be your equation, x equals a number, and for a little review, your slope of this is undefined. Part D looks like it hits the y-axis at y equals negative 1. So my equation would just be y equals negative 1, because as you look along this line, the y is always negative 1, x consistently changes, so this would be your only equation. As a little review again, your slope has no steepness, but it is possible, so your slope is 0.